Welcome to Part 2 of the lecture series on multiplication and division of real numbers. In this section, we will be looking at multiplication and division of fractions. In the first part of this lecture series, we looked at multiplication and division of integers. We will begin this section with multiplying fractions. We will use variables to represent numbers and start with the property for multiplying fractions. Let A, B, C, and D be non-zero integers, then A over B times C over D equals A times C over B times D. Notice that all we are doing is multiplying the numerators and multiplying the denominators. When we're using strictly variables, we can rewrite this without the multiplication symbol as AC over BD. But when we use numbers, we must separate the numbers with some sort of multiplication symbol. We will look at some examples of multiplying fractions. We will write the answers in lowest terms. Using the property, we will start with 3 over 4 times 7 over 5. According to the property, we multiply the numerators and we multiply the denominators, giving us 21 over 20. This fraction is already written in lowest terms, since the only number that will divide evenly into both 21 and 20 is 1. The second example, we will again multiply the numerators and multiply the denominators. This gives us 175 over 600. We will now try to write this fraction in lowest terms. The best way is to find what we call the greatest common factor. We will look at this in a later section. But for now, just try to determine the number that will divide evenly into both the numerator and the denominator. It is easy to see that 5 is one such number. If we divide 5 into 175, we get 35, and if we divide 5 into 600, we get 120. So we can rewrite this as 5 times 35 over 5 times 120. Now, we can cancel the 5s, or we can look at that as 5 over 5 is equal to 1. Regardless of how you describe what you're doing, you end up with 35 over 120. Again, this fraction is not in lowest terms, but it should be easy to see that 5 goes into 35 7 times, and 5 goes into 120 24 times, giving us 5 times 7 over 5 times 24. Again, 5 over 5 equals 1, or we can say we're canceling the 5s, leaving us with 7 over 24. This fraction is in lowest terms, which is our final answer. To make multiplying and reducing the product easier, we will look at cross-canceling before multiplying fractions. So before multiplying two fractions, we can cross-cancel factors that are common to the numerator of the first fraction and the denominator of the second fraction. Then we cross-cancel factors that are common to the denominator of the first fraction and the numerator of the second fraction. We will look at cross-canceling before multiplying the following fractions. We will start with 7 over 20 times 25 over 42. Notice that in the numerator of the first fraction is 7, and in the denominator of the second fraction is 42. These two numbers have 7 in common, or 7 will divide evenly into both of these numbers. That is, 7 goes into 7 one time, 7 goes into 42 6 times. Also notice that the denominator of the first fraction has a 5 in common with the numerator of the second fraction. 5 goes into 20 4 times, and 5 goes into 25 5 times. This reduces our product to 1/4 times 5/6. When we multiply the numerators and multiply the denominators, we get our final answer, 5/24. This is already in lowest terms. For our second one, since we are multiplying a negative and a positive, the final answer will be negative. But for simplicity, we will first multiply without regard to the signs, and then we will apply the appropriate sign rule to the final answer. We will be multiplying 32/11 times 33/8. Notice that 32 and 8 have 8 in common. So 8 goes into 8 one time, and 8 goes into 32 4 times. Notice also that 11 and 33 have 11 in common. 11 goes into 11 one time, and 11 goes into 33 3 times, leaving us with the reduced product 4/1 times 3/1. Multiplying the numerators and the denominators gives us 12/1. But anytime we have a number in the numerator and a 1 in the denominator, the answer is just going to equal to the numerator. But remember, our original problem is a negative number times a positive number, so our final answer to part B is -12. We will now look at dividing fractions. We will let variables represent the numbers to describe the property for dividing fractions. Let A, B, C, and D be non-zero integers. Then A over B divided by C over D equals A over B times D over C. Notice what we have done. We have kept the A over B, or our first fraction, as is, and we are now multiplying it times the reciprocal of the second fraction. That is, we are flipping the second fraction, which is called the reciprocal. Now, we can use the rules for multiplying fractions. We multiply the numerators, multiply the denominators to give us AD over BC. Another way we can write this is as a compound fraction. A over B divided by C over D as a compound fraction. This equals A over B times D over C. Notice that we're changing the compound fraction into a product of two fractions by keeping the numerator as is and taking the reciprocal of the denominator and multiplying the two. This gives us AD over BC. We will start with an example. 24/35 divided by -33/25. We are dividing a positive by a negative, so the answer will be negative. But for simplicity, we will first perform the operation of division without regard to the signs, and then we will apply the appropriate sign rule to find the final answer. Starting with 24/35 divided by 33/25, we use the property above. Write this as a multiplication problem, 24/35 times the reciprocal of the second fraction, 25/33. We can now cross-cancel and then multiply. Notice that we can divide 3 into both 24 and 33 evenly. 3 goes into 24 8 times. 3 goes into 33 11 times. Notice that 35 and 25 have 5 in common. 5 goes into 35 7 times. 5 goes into 25 5 times, leaving us with the reduced product 8/7 times 5/11. Multiplying the numerators and multiplying the denominators gives us 40/77. But remember, our original problem is a positive number divided by a negative number, and by the rules of dividing unlike signs, our final answer is negative 40 over 77. We will now consider another example. This time we're looking at a division problem in the form of a compound fraction. Notice that we are dividing a negative by another negative, so the answer will be positive. But for simplicity, we will first perform the operation of division without regard to the signs, and then we will apply the appropriate sign rule to the final answer. So we are dividing 17 over 18 by 34 over 63. Using the property for division, we write 17 over 18 times 63 over 34. 63 over 34 is the reciprocal of the denominator of the compound fraction. We can now cross-cancel and then multiply. Notice that 17 will divide both 17 and 34. 17 goes into 17 one time, and 17 goes into 34 two times. Notice also that 9 divides 18 and 63. 9 goes into 18 two times, and 9 goes into 63 7 times, leaving us with the simplified product 1/2 times 7/2. We multiply the numerators and multiply the denominators, giving us 7/4. But remember, our compound fraction is made up of two negative fractions. That means we are dividing a negative into another negative, but when the signs are the same, we get a positive answer. When using the calculator to divide fractions, be sure to put parentheses around the fractions when necessary because of the order of operations. We will be discussing order of operations later on in this course. We enter this compound fraction as follows. Open parentheses, negative 17 divided by 18, close a parentheses. Then divide that by open parentheses, negative 34 divided by 63, then close the parentheses. When you enter, you will get 1.75. Most calculators will allow you to convert this decimal to a fraction by using answer then fraction, which will give you 7/4. Later in this course, we will be studying how to convert decimal numbers to fractions and vice versa without the use of a calculator.